Let's take a look at some Kirchhoff's voltage laws and a little problem here. So first of all, I want to talk about the mathematical equivalent for this law. And basically what this is saying, and this is the summation of the voltages is going to be equal to 0. Okay, so if you're looking at a branch, the sum of the voltages is going to be equal. So if you look at our circuit here, you can tell that there's a loop here, a branch, and there could be a branch here. And what I'm going to do is I'm going to go ahead and I'm going to add, one more branch here for later on that we look at, okay? And there'd be, there could be a branch here or a loop here, a loop here. So we got different ones, but the sum of those voltages has to be equal to 0 for a given circuit, all right? And so if we want to look at this first circuit right here, that's just this one right here. So what we do is going from positive to negative, we're going to put the directional arrows on the voltage, so they're going up like this. And we would call that, let's say, positive voltage, all right? So this is positive. So if everything going up was positive, then that's what this direction is showing here. But here the arrow is coming down, okay? So we've got positive arrow and we've got a negative arrow here and a negative arrow here, okay? And so what that's saying is that the sum of the positives and the negatives is going to be equal to 0, okay? So that's what we're trying to do. We're trying to get the sum of this this voltage minus this voltage minus this voltage, okay? And it should be equal to 0. So if we take a look at this first loop right here, or this first voltage drop right here, remember for all these voltage drops, we're dropping from this potential up here of 100 volts down, down to 0. If you want to think about that, we're dropping 100 volts here, okay? Because they're in parallel. So if we look at the ratio here, the first one we're going to take a look at is this one here, okay? So this resistor is 300, and this resistor is 300. So we know that our total is going to be R1 plus R2. So if we go 300 ohms plus 300 ohms, we get 600 ohms, okay? So there's a 600 ohm resistance here. So if we're dropping from, 100 and we're dropping 100 volts across here, and we notice that these two are equal at 300 ohms, can't you see that each one is going to drop the same amount of voltage because they're equal here? And how much is each one going to drop? Well, the total here is 600. So each one's going to drop 300 over 600, or exactly 50%, because they're the same. So half is going to drop through here, and then half is going to drop through there. So when we look at the voltage drop here, we can take 100 volts and we can multiply it by 0.50, which is 50%, and we'll get 50 volts. So this is going to drop 50 volts, and this is going to drop 50 volts, because we have to drop a total of 100 volts here. The resistor is the same, so it makes sense, 50 and 50, okay? Let's look at another one right here. Let's take a look at this one. So this one, the total resistance is 1,000 ohms. We got 750 ohms plus 250 ohms is 1,000 ohms. So if you look at the first one here, 750, well, that's 750, the ratio out of 1,000, because the total is 1,000 here. Well, that's 75% of the voltage drop. And this one here, this is going to do 250 ohms. We should have ohms on these, out of 1,000 ohms. Well, that's going to drop 25%. And these have to equal 100%. 50 and 50 is 100, 75, 25 is 100. So if you look at this again, it's 100 volts that drops from here to here, no matter which path you take, dropping 100 volts. So if we have 100 volts times 75%, we get 75 volts. So we can see that this one right here is going to drop 75 volts, and this one's going to drop 25 volts, because that's just the percentages. And just like these ones were equal So we expected them to go 50 volts and 50 volts. I'm just going to do one more right here. I could do, we could do maybe thirds here. No, let's just do 600 ohms, and let's do 400 ohms. We'll keep it simple, okay? 600 and 400. How much voltage is each one of these dropping? Well, we know that these add up and they make 1,000 ohms. So this one, you can tell one's going to drop more than the other because they're not equal here. So these are 1,000 together. And so what percentage is this? This is 600 out of 1,000. 60%. And this one is 400 out of 1,000. And it's 40%. So we got 60% and 40%. So if we're dropping 100 volts here, isn't this one going to drop 60 volts? And this one's going to drop 40 volts. Okay? And so there we can get voltage drop through here without going through all the Ohm's law calculations and everything like that, just by realizing that the percentage drop through here has to equal 100%, and we can multiply that percentage by the amount of voltage. The math was really good and really easy here because we were multiplying it by 100, but if it wasn't 100 volts, we would just multiply that, whatever that voltage was, by the percentage drop, and that would be how the Kirchhoff voltage law works for your branch ratio.